Everybody, as we push the boundaries of AI, how close are we to achieving the holy grail of building systems that mimic human reasoning and enhance it? I'm your host, Alex Kehaya, and today on Everything Bagel, which is a sub-show of the Index podcast, I'm joined by my co-host, Bidhan Roy, founder of Bagel, and we're going to explore and discuss around the agentic future and dive into how Bagel is revolutionizing open source AI with its monetization layer and innovative use of cryptography. This is a topic I'm really excited to talk to you about today because I think I have like some grasp on like what's coming or what's already possible, but there's just so much happening. It's been hard for me to keep up. Like high level, what does the agentic future mean? Like what is an agent, an AI agent? Can you explain that to me?
Yeah, I mean, it's all the rage at the moment. Everyone is talking about agents, agentic future. Like some of them are open source and closed source, and they have different meanings to different people too. So if I kind of say that this is what is an agent, and there will be like 10 other people coming after me like, oh, you're wrong. We think this is an agent, not that. But I'll just say my definition of it anyway, my interpretation of the word agentic. So what when I hear agentic, I mean, I think an AI system which is equally capable as a, really talented coworker, right? So what happened? Like we had these AI systems initially, which were kind of toddler-like. Like we used to ask it question, it will give us some answer back depending on what it memorized and whatnot. But we still had to do some kind of planning if we wanted to achieve some goal using that AI, right? But then, as more and more capabilities were pushed into these AI models, they all of a sudden started growing up. And now they have gotten to a level where they're an adult. And what does an adult do? They can do planning and take decision and execute it on their own. They don't need guidance at every step. So I think that's what's needed at minimum to be considered an AI agent. For me, the agentic behavior is that when you give some high-level instruction to an AI system, it can plan, it can consume new information, it can browse the internet to do some research, and then it can define an action item from the vague input you gave and then execute on it on its own. So all of those intermediate steps were executed by the agent itself, not just human, like hand holding it, right? And for me, that's agentic behavior. So if an agent can plan and execute at the same time without human intervention, then I can call it like something which has an agentic behavior.
I mean, the comparison, it's an agent, right? So when you think of an agent and that's not an AI, you think of like a real estate agent or a travel agent, right? Like they help you do something.
I like that.
You make a request to a travel agent. Like,
you better go. Like, a lot of people say real estate agents don't do much. So there's that.
Yeah. Well, it depends on the agent. I had a couple really good ones. But I think maybe a travel agent's probably the best one to think about because like, what does a travel agent do? You give it some parameters of like, hey, I want to travel to Greece with the family. There's, 5 of us. That we have budget is this range, plan my trip, get me a package. And right now a human being does that.
The details, go figure it out on your own. All right.
That's why I would hire an agent. Like if I was going to be more specific than that, then I just plan the trip myself, and so that's the parameter, that's the prompt you would give an AI to go plan your travel for you. And that would be agentic behavior. It could do all the reasoning it needs to do to like make a plan and actually go book those, come back to you with a plan and then be like, here's the plan, here's the pricing, what do you want to do? And I say, yeah, I want to buy that. And then it can go do it for you. That's agentic. That's an right? So are we there yet? Like, do we have AI agents that are like that sophisticated where it's actually doing things like end to end?
So I'll be honest. I don't think we are quite there yet. Like there are AI systems which can do like high level tasks, right? And like I'm an engineer, and like in at Bagel, I do technical work, and I can tell you the evolution I have seen among coding agents. Like coding agents were initially they just complete your sentence. Like you write one line and it completes that. That was the first version. The second version of it, it can write a whole script. You can tell it like, hey, write me some script in Python. It can do that. And the newest systems in the coding agent space, like things like Devin and whatnot, which got a lot of publicity recently, they can act as a junior engineer where you can tag it on some minor bug and it can go search online, read up some things and figure out how to solve that bug. So it's there.
I mean, even that alone is incredible, right? Like, and that's the crazy thing. And like, I use GPT for this, and it's not very good actually when you start doing like anything really technical. But it can read Stack Overflow like it's read all of Stack Overflow. So if I have just like a vanilla bug error message that I want to paste into GPT, and it accelerates the time to me figuring out how to debug it right now. And so these junior version of it, right, like is kind of like that, except taking it the next step where it actually gets you the real answer. But let me ask you this: does it test it? Does it know that it fixed the bug, or does it just say, "Hey, this is the answer," and then it's not really the answer?
It does, yeah. Like,
Wow.
It basically you tag it on on an issue on GitHub, and it creates a pull request from it. So it does.
That's crazy. That's crazy. You know, that's really crazy.
Per month, right? How much does a junior engineer cost? Way more than that.
Oh my God, yeah, for sure. Yeah, I mean, it's interesting. I mean, how fast is this accelerating? I mean, I've heard people talking about like replacing most coding jobs getting just replaced in like years, not decades, like years.
So I think that's where we're going, unfortunately, for a lot of people. I think the thing is, the biggest, I guess, barrier to executing something great or building a great project, it's not about writing the code itself, right? When there's a bug, your system is down, or Linux kernel is not working, your file system is messed up, your Python environment is broken, which is an AGI level problem, like fixing broken Python environment. Oh my God. If an AI can do that, I'll say like it's AGI. It's so hard. Some people are like, I'll just change my laptop. It's so hard to fix a Python environment if it's broken. So those are the hardest problems. Like my more than a decade long career of writing code, that's where I spend the most time, right? The writing actual code is very small part of it. And that part is going away for sure. But do I think all the other person debugging, they will be taken over by AI too? I think so. The end of the day. But we're not there yet. And I actually think we're quite far from it.
Yeah, I mean, so let's talk about this a little bit, like the path to that, right? So you need for AI to be really good at this, to really have agentic behavior. It needs to be able to reason, so like think through a problem and come up with the right answer. And then it also needs to be able to learn, like improve, to really be, when it knows it did it wrong, it's got to be able to figure out why and fix that problem. And
exactly.
Let's talk about the reasoning piece, because you guys have some research on this, right? Like, and there's some trade-offs between the different types. And I think this is something that people don't understand. Like the intricacies of this is kind of interesting. But you guys talk about on your blog, arithmetic reasoning, common sense reasoning, and symbolic reasoning, and then the different training time methods. Can you explain the three different types of reasoning and kind of how that plays into the development of agents?
Yeah, I think going to the different types would not be useful. I'll just say that, like, I'll keep it higher level here.
Yeah.
Where it's like, the reasoning is basically understanding something. So there's this big debate in the AI world nowadays, like, do LLMs really understand something, or they're just, there's a term, it's called stochastic parrot, where they're just, repeating things they have learned during their training time. Like whatever data you put in, it just kind of mimics it. It just mimics a human which can think, right? That's like one side of the AI world say like, hey, this is what it is doing. And the other side are saying like, no, they can actually think. But we don't really know. It's a hot topic. And one of the reasons we don't know is that all of these neural networks are really black box things. Like all these cutting edge researchers, like OpenAI researchers or wherever you can think of, none of them know how this works.
You said that last time we talked, and I've read this a couple of times in different places.
Yeah.
Why is that? Like, it's kind of crazy. Like, you set up a neural network, which is like, first of all, explain to people what a neural network even is. And then let's talk about why it's a black box. Like, what is actually, how do we not know what's happening in there?
Yeah, like neural networks are basically these AI models, right? So we built these AI models to mimic maybe our brain. And they're like small units of, decision making. We call them neurons. And what we do is like we put the AI models in layers. In one layer, there are a lot of neurons. And then that layer does some, calculation on input data. And then it transforms it in different ways. Those are called activation functions. And then it sends it to the next layer. And that sends it to the next layer.
Oh,
That ends up going to the output layer. And that's when you get whatever output you get. And the thing is,
okay, sir,
we got with all these models, all these like cutting edge models, all of them were, most of them were achieved through trial and error. It wasn't a scientific method where we knew that if we do this, we'll get this output. We're like, okay, let's try this. Let's put more data. Let's change the activation function a little bit differently. And let's put a little bit of bias in the layer to layer, or let's increase the layers. So what we did is like more similar to biology than computer science. In biology, what we do, like we experiment with the human body, like, hey, let's trial this drug if it works on, animals, then human testing and all of that. Like that's exactly how we came to these very sophisticated AI systems. We just did trial and error. Like, do we know deterministically? Like if we do this and that happens, and this is the reason that happens, we don't know why it happens most of the time. So this is how we ended up here. And that's also crazy. I mean, that's kind of, I know, like a lot of AI doomer people say that we don't know how these work. And that's how we will we'll end up giving them the power. All these AI models will mimic being aligned with us, but they'll not be anymore.
Yeah, you don't know what they're actually thinking. You don't know how they're working.
Anthropic yesterday released their research on that. It said, it's crazy. Like, I don't know if you read that. So Anthropic ran a research on its own model to see if it's aligned towards whatever goal or whatever values Anthropic wants it to abide by. And it was aware, the model was aware it's going through that evaluation, that it kind of faked the alignment during the testing.
What?
Isn't that crazy? And they came up with this, they released this research. They're like, okay, our own model is mimicking alignment with us. So
that's crazy.
Yeah, like one of my goals is to, whatever we're doing, first of all of these models are closed source, so not a lot of people can look at it. That's also one of the reasons, like we don't really know how they're being done, or they're so much black box for us. But one of my goals is to have these massive, powerful models, but in open source. Mm-hmm. And then we will have like not just hundreds of people in the small companies, we'll have millions of people looking into this. And that's our actually best chance to avoid the doomsday scenario where this model, like these 200 people, they don't know what's going on. They're going to do something wrong and things will blow up. Only way to avoid that is that if we have this in open and everyone kind of have their eye on them.
Yeah, that makes sense. I mean, so I want to make sure I understand, going back to the neural network thing. You talk about these layers, and is it like, I just use the bagel example, right? So I'm like fine tuning a model. I've created parameters. I'm fine tuning a model to give it certain behavior, right? And then you fine tune a different model, or the same model, but you do add parameters to get different behavior to it. I might stitch together a neural network that's like my model and your version of the model, and my model does some stuff with the prompt that I give it, and then your model does something with the output of that, and it kind of keeps going like that around until you get the final output. That's like a neural network, and the layers, each layer is its own LLM with its own set of fine tuning and training and stuff that's happened to get specific behavior out of it, and then that's running. Each one runs on its own server. Like it could be like 1,000 servers with 1,000 layers could make up a network. Is that
Yeah.
basically what it is?
Partially. So, I mean, some base model, even one fine tuning can add like multiple layers, right? So there's that. And a base model can have a lot of layers. So, so how these layers work is like you add layers and you get the output. But in the bagel example, when a contributor contributes some parameters to a model, they can add one layer or they can add multiple layers. It depends on how much data they're putting in, how much calculations they want to do, because multiple layer definitely takes more compute and GPUs and whatnot, right? So it depends on a lot of things, right? So it's possible to have one layer just with one person, but that's not the most efficient. The most efficient is like have multiple layer with multiple people. And when it runs, that can also run in a decentralized way, in like in a lot of machines. But the best way to do it, we have seen, is that like get all of this layer together and run it in like machines, less number of machines, like one or two instead.
Mm-hmm. That makes sense. And so like we talk about reasoning, but we haven't actually talked about how do you, like, if it's not reasoning correctly, how do you get it to reason correctly? And that's like fine tuning and training. But I think, well, I guess we're going to be getting into AGI if I talk about this, but AGI is artificial general intelligence, which is like a level up, I would say, above agent, right? Like an agent, not like you could build an AI agent that can do these complex tasks for a specific thing, like travel agent, right? Like a travel agent.
Yeah.
But it wouldn't be like generally intelligent where it can do a lot of different specific tasks, right?
Exactly.
And even in both cases right now, under my understanding of the current state of the world, everybody uses large language learning models. And so in order to fix any kind of problem, like if an agent isn't behaving properly and it gives you the wrong outputs or fails to book your trips properly, right? Like you have to go train it again. So you got to like go back, run more data through it, change the parameters and like fine tune and do that experimentation you're talking about, right? Like kind of randomly seeing what happens. But one of the things I talked to you about with Peter, what was his name? Just let me look really quick. Peter Voss, the chief scientist of IGO, was about cognitive AI. And so Peter Voss is actually one of the three guys who like coined the term for AGI. And he was talking about like, he basically told me that all these universities and companies started investing in LLMs. And that became kind of the hammer and the nail that like everybody got trained on. But it has this challenge where you have to constantly retrain everything on large amounts of compute. And that takes a lot of time and energy. And he posited that cognitive AI is different than that, where it's like, it can kind of learn on the fly. Like, and I don't know exactly how it works, but have you heard of that? Because that seems like a really big problem for like the LLM space, right? If that's, that space, are you aware of this? Like, what are your thoughts?
Yeah, no, that's actually one of our research focus too, like doing things.
Is cognitive AI?
I mean, cognitive AI specifically, I don't know what it exactly is, but I'm talking about like the overall field in general, where you can edit an LLM without retraining it from the scratch. There are a lot of ways to do that. Like the easiest way to do this, like, do calculation in inference time, they're called like in-context learning, where you can put more information into the prompt that you're giving to an LLM, then it knows about certain stuff. Then it can be a little bit more logical and a little bit more knowledgeable about certain knowledge that you're putting into the prompt. So that's called in-context learning. Like you basically put the information in context of the model. But the limitation for that is that the model's context is limited. Some models have like 32,000, some models have 200K and whatnot, but it's still limited knowledge and limited, context length. And there are a bunch of other ways you can do where you don't have to put it in the prompt itself. Like you can actually put new information on top of your model. That's where a lot of these fine-tuning technologies that we're working with comes in, where you don't have to change anything in the base model, but you can add an adapter on top of the model. It's like a plugin, like if you add it, it's like an app that you download on your iPhone, then all of a sudden that app can do new things that your iPhone couldn't do. And that's kind of focus of our research, where you can add this adapter or plug it on top of a model, and all of a sudden it knows how to do that, which you didn't know how to do before, and you don't need the retraining from scratch. So
how far along are you guys in that research process? Like, have you had some breakthroughs yet, or what do you think? Where are you in the
we're
process?
about to open source a lot of things, but I will say we have made breakthrough in the process where a contributor can contribute some adapter to a model, but at the same time, they have the ownership to that adapter.
Oh, cool.
What that means is that you can add a plugin on a model and make it open source for the community to use. But at the same time, you have ownership, as in when the community wants to use it, they will have to make payment to you. Otherwise,
yeah. I love the App Store analogy. I think that's amazing. I think the fine tuning piece is the same. Another really great analogy. You've got adapters and you got fine tuning. Is the adapter the same thing as fine tuning? Like giving it different parameters?
The adapter is a subset of fine tuning technologies.
Okay. So it's part of the same picture. And I like thinking about it as specific apps with specific functionality. I think it's a great way to put it.
But at the end of the day, fine tuning is just the start. Like we had this breakthrough where we have built this almost new model architecture for open source models, which has the monetization, privacy, and ownership baked in to the model in a cryptographic way, not just through licenses, right? Like in licenses, you say like, hey, please don't use it for commercial use case, and people do it anyway. Here, the ownership is encoded through cryptography. And we have built this, and the things you can build on it are limitless. Like fine tuning is just the first one, the use case that we're going after. But going back to the reasoning part, like that's actually one of the most effective ways to enhance reasoning in a model, right? We have seen, and there are lots of other ways you can do that too. There's another technique or another area of research which is getting really popular for increasing LLM reasoning. They're called test time compute or inference time compute. What that means is that you don't burn more compute while training by putting more and more data. Instead, you give the model more time to think. So the model is kind of built or fine-tuned or trained in a way where you could tell it like, hey, just take more time, take some information and think about it. So it does processing. And
but we don't know what's happening. We don't know what it's thinking, right? I mean,
we actually, for that, we actually do what it's thinking. That's the interesting part. I can see the steps with that. So it's actually a little bit more transparent than the training.
Oh, okay. So you can see the steps. So does it, by taking more time, does it like know it came up with a bad answer and then like fix it? Or how does that?
Yeah, like you can train it in a way that it can have some function where it can evaluate its answers and the intermediate answers. And depending on that, let's say there are two different possible answers or paths it can take in its thinking process. It uses that function to evaluate which kind of branch it should go in the reasoning and take. So it's very interesting research area at the moment. We are also personally very interested. We have been looking into it, like how can we, fine tune a model, like a normal model, and make it change it in a way where it can actually think instead of like just repeating stuff from training data.
How are you guys cranking out this volume of research? Like your blog is pretty extensive. You've shipped a ton of open source stuff. You've made some pretty crazy breakthroughs or in various areas. Like you're a pretty small team, right? I mean, it's not like you have hundreds of researchers. You've got like how many people?
I mean, our research team is 3 people.
Yeah. Like that's crazy. The output seems like a lot.
This comes from our experience. So what happens is that, like when you do something, it's not just what you're doing at the moment. It's whatever you have learned over decades before, right? So our team has been working in this problem space for a long time. Me personally have been in the machine learning space for more than a decade and been thinking about this exact problem, how to monetize open source AI resources for more than 5 years now. So one of my team members, our head of cryptography, he has been doing cryptography since before Bitcoin. Like he has published more than 30 research papers, all of them original. So, and we have our machine learning person who has been, who were doing research for Microsoft Copilot, GitHub Copilot for almost a decade. So I feel like we are a small team, but we are all aligned. We have been thinking about this for a long time, and all of that are coming true right now. And we're passionate about what we're doing. This movement that we're building, monetizable open source AI, that gets us up in the morning and all fired up to do great work.
How do you balance the workload though between like developing the product, because you're trying to build a product with a marketplace for monetizing open source AI with the research, and it's kind of dog fooding. Like I get that the research impacts the product, but
exactly.
It's still a really tough balance to strike with a small team. How are you guys handling that? Just curious.
The handling is just handling it by not sleeping. That's how it works. It's just hustle. I can give you some really clever answer to that. Like this, we just hustle a lot. That's it. And all of us are really passionate about what we do. And that's what makes the difference.
Amazing, dude. All right. So one current event question I want to drop on you that's sort of unrelated. But you've met Greg Osuri from Akash, right? I think you guys have spoken. So I was an early investor in Akash, and early on they built, or were going to build, I don't know if they ever actually shipped many of these, but they had this thing called the Super Mini, I believe it was, like a little computer that was supposed to be like an Akash node you could have in your house. And it was a really cool idea. And I saw on Twitter, all these people were tagging Greg because NVIDIA released their little mini computer that like you can run an AI on locally. But did you see that? Did you see the mini computer announcement?
The
Jensen?
See that.
I'll have to share it with you. But they shipped like this little computer with a chip in it for doing AI locally. Like you can run like a model on it in your house. And I guess I was wondering what you might think about that as far as it relates to the development of AI. I wasn't really sure. Like, seems like people are really excited about it, but I didn't really understand exactly why.
I think I saw it. It's a model that can run on a small hardware, so that it will take robotics. I see. It's also kind of specialized hardware. I think that's makes sense.
Yeah.
No, it's super interesting for sure. I mean, robotics is actually one way to. I feel like that's one of the very few ways we can gather more organic data, which are not garbage. So what happened? Like we have been. It's actually a big topic now. Like last week at New Reefs, where I was, it's a big machine learning conference. There were a lot of talk about like we are hitting a data wall. Like we don't. Some data is the fossil fuel of AI, where we have it somehow. We didn't mean to have it, but now we use it to build things. But the internet is becoming more and more crowded with data which are generated by other AI, right? So in future, we're not going to get much organic data to do things. But I think robotics is one of the ways where which we can use to gather more organic data from real world. Like if you just, like Tesla, for example, is doing a lot of that. Like Tesla cars are basically robots, and they have a lot of cameras and it's recording all the time.
Yeah.
Or if you have a specialized hardware that NVIDIA released, which you can put inside a robot, and that can walk around your home or outside, that can also collect data which are real data. And that's actually one of the ways you can gather way more information which are valuable in a scalable way. So robotics as a data collection system is something I think has a lot of potential.
Well, this does tie back to the agents, right? Like I've been seeing on Twitter about how, we're going to have all these agent bots trading against each other and just like doing everything that we do basically. But if you take it in crypto native use cases for that, like and we were kind of talking about this earlier, I think on the last episode, like what does the world even look like when 90% of the internet is just AIs talking to each other?
What do you think? How's it going to look like?
It kind of makes me think of that kids movie, that Pixar movie WALL-E. Have you ever seen WALL-E?
Yeah.
So it's like the little robot, and they're like all the agents, and then all the rest of us are just like obese and in chairs, just like drinking shakes, being like shepherded around for entertainment. I actually had a conversation about this with my co-founder, Brian Fox, who's the author of The Bast Shell. I've told you about him a couple times. And he just thinks that, yeah, I mean, eventually it's going to eliminate like most things that humans do, and that society optimistically will end up in a place where, we're just spending our time doing other things that we want to do, like creative tasks and stuff like that. But
yeah,
I don't know.
I think I agree with that, like the creative stuff and stuff like that. Maybe like the Wally version problems are not gonna happen, because I was thinking, like I usually don't even take weekends off, but last weekend I took one day off, like a normal person. And what I was doing, I was like really excited to go do yoga that day. So I signed up for a hot yoga class, right? And that's what I was doing in my off time, in my leisure. So if AI takes everything, I'll probably do that more, right? Like things not necessarily harming us. Like there are things we enjoy which benefit our mental and physical health as well, right? So we'll probably do that. But it's kind of a black hole, to be honest. Hard to predict what's going to happen.
Yeah, I mean, it could happen. We don't really know.
I mean,
but I also think
if AI takes your job, then you're going to do jujitsu all day.
Yeah,
right.
Yeah, for sure. Yeah, I'll just do jujitsu every day. Yeah, I mean, I think that is the one thing that kind of concerns me about like just the rapid pace of development in this area. Is just like, so will society be able to even keep up? It's happening so quickly. But then again, you kind of like when you start looking at the research that happening, like you guys are cutting edge on the bleeding edge of the research here. Like there's still a lot of work to be done, and I don't know. And then you get Willow getting released by Google and you're like, oh, well, fuck, I guess quantum computing is like already done. So, I mean, there's also, but then go ahead.
That's a black hole. Quantum computing is actually, everyone kind of counted Google out, like in the AI race, like OpenAI, Anthropic, Microsoft were winning. But if they have quantum computer, like none of these matter. Like if they have quantum computing technology, they can make GPT-5, a new GPT-5 every day with a quantum computer. And right after that, they're releasing this massively. Did you see their video model release? It's called VO2.
I lost like the last 20 seconds because my headphones just disconnected, which is why I'm looking around. What did you say?
I said, did you see their new video model release, the VO2?
No,
Google. Oh man, it's like so much better than the one from OpenAI. So Google is definitely back in the race. And if they have quantum computer internally, like Willow, I think that changes everything. Like whoever has that, they're the king.
Wow. I hadn't seen it. I got to go check that out. Well, we're getting towards the top of this episode, but was there anything about like agentic AI that we wanted to cover that we didn't talk about?
Agentic AI, not necessarily. Yeah, I believe that something will happen in future. Like right now, we are getting right now we're at level 1, where a lot of people are building these agents, which are kind of a wrapper on top of these foundation models that are held by these closed source companies, right? Like all the agents you see on Twitter, they're just usually some wrapper on top of Claude or GPT and whatnot. The second stage will be where a lot of these models will be their own foundation models. And that's where we're moving already. Like some of them are moving towards their own foundation models, which they use to do things. And the third stage would be where multiple people or a big community are building these foundation models together, and that is powering the agents. And it can be a community which is aligned for whatever, like some decentralized science community coming together and training a pharmaceutical model together or building it together. And I believe that we are building that critical infrastructure that will power that, like enable these massive communities to build open source model in collaboration with each other. And also they have the incentive to do so. So really looking forward to that future and working towards that.
Yeah, that sounds amazing. Well, look, I'm looking forward to continuing. It's December 19th today that we're recording this, and then we're going to be on a little break here. But can't wait to do another episode with you in early January. I think we're going to have a guest coming on from another company to do some, be part of the conversation. And I just wanted to put a call to action for everybody listening to this. Like, if you're interested to come on and want to talk to Bidhan and I about the research you're doing, the innovative, you could be a researcher, you could be a company, a founder of a company. If you're working on open source AI and you're doing innovative research and cutting edge stuff, we want to talk and have a conversation about it and share more with our audience about what you're doing. So, you can find both Bidhan and I on Twitter. I'm just Alex Kehaya. You can look me up. And then Bidhan, what's your Twitter handle?
It's Bidhan, my first name, then XYZ.
Cool. BIDHAN XYZ. You can find him on Twitter as well. DMs are open, and Happy New Year. Happy holidays.
Happy holidays, everyone.